All right, this is our first module on databases, Lecture 1.1. So why are databases even important? Well, let me ask this question. Can you think of one business that does not use information? Now, with that information, the next problem becomes, how do they store it? How do they use it and retrieve it, blend the information together to come up with strategies and tactics? This is the beginning of databases. So what I'd like to do is take you out, first off, to database information consumption, and just show you some information about what's happening out there on the world of databases. When I was taking a course this summer, I learned something very interesting from a professor. Oops, there's my kitty. From a professor that by 1997, the internet doubled information every 7 years. By 2015, the internet doubles information every 35 days. Now, to put it in perspective, when you begin this course, if you were to measure the quantity of information on the internet the day you start this course and the day you end this course, the quantity of information on the internet will have doubled. Now try to keep up with that. Hence the reason for storage of information. Well, let me take a look real quickly at this particular website now that I've got it up and running here. I wanted to bring it down and just show you an overall kind of a synopsis of the history of computing from 1982. Oh my God, that's when I first went in the Army. All the way through the networked era, through the 90s. This is when the World Wide Web came around. 1993, World Wide Web. 1994, 95, Windows 95 came out and was the first one to actually introduce IP inside the operating system. Now we're getting into the late 90s. E-commerce is starting to become around. SSL and secure socket layers are introduced. You see some of the growth of some of the other nations. Look how information is being processed now. Not only that, but the volume of data being able to transfer across a wide area network is also increasing with distributed wave division multiplexing and fiber optics. Interconnected era. Here we are today. Here we are. Look at this. $1.5 trillion in 2014. $7.1 trillion by 2020, and the introduction of the brand new concept of the Internet of Things. That's an interesting concept. We're going to cover that in the very last module of our course. I just wanted to give you a brief view of what's happening as far as data consumption on the Internet. So let me show you how SQL sets within the software engineering field. There's a very popular diagram that I love to show all my students when I teach about databasing on the internet. Let me open up the web browser again. And this, I love this drawing that this person has done. What he's done here is he's taken what you've already learned as far as procedural programming, imperative programming, like in Python, JavaScript, Java, Alice. Alice is what I teach over at the Oracle Academy, which introduces people, young kids, middle schoolers, into Java programming. And when people get into SQL, they go, oh, this is so hard. Well, it's because it's different. It's more on the declarative side of software engineering. It's not programming line by line, what you're accustomed to, but it's asking the database, here's what I'm looking for. The database gathers your declarative requests, goes out, finds the information, collects it, compiles it, and then gives you a view of that particular data that you've requested. Very easy to find out on the internet. I'll let you search for that. As we go through this book, I'm not going to read it to you. What I'm going to do is I want to show you a couple of things that I've done for you in the textbook. So let me grab the first off here, our database management textbook, Concepts of Database, edition number 7 by Pratt. Very, very fast-moving textbook from what I've seen in the database books. And what I've done is I've got some highlights in my author notes here. And as I go through and I highlight things in the book, these are things that I believe are important in the topics. Some things that may impact you on your assignments, This peach-colored, grapefruit-colored one here needs for clarification. I may not agree with absolutely everything in the author that he states, so this is where I've expressed my views compared to what he has, and let you make your own decisions on which you would rather do. Quizzes, real life experiences, what I've experienced in my 37 years of exposure in the industry, and highlighting what I found to be beneficial for me, learning the hard way, and help you also kind of ease the blow of things that you may encounter. So in our book, as I said, I'm not going to read it to you, but in the table of contents, the chapters are divided up into several pages apiece. And just as an illustration here, a couple of pages into the preface, there we go. Here's some peach-colored stuff about the advanced topics. And I've highlighted some of the things that I may disagree with, just to illustrate that. Here's some green that I do agree with, and I've seen this in the industry. So jumping over just to Chapter 1, Chapter 1 is not very large. It's only about some 28 pages before we get to an end. The very first page, nothing there that I thought of was interesting, but then all of a sudden I found some very interesting things about how the spreadsheets are compared to databases. And if you're familiar with Excel spreadsheets, then you know about the columns and the rows. A relational database is very similar to an Excel spreadsheet in that the columns, the up and down ones, refer to similar data across all of the records, which are the horizontal collection of information about one thing. The other nice thing about our textbook is they have a lot of questions and answers, and having gone through these questions, I see that these are very common questions that are normally asked in the classroom, and this will benefit you that if you have similar questions, the answers are given here by the author. I encourage you to ask the same questions on the question and answer inside of our course content so that you can see my perspective on the topics also. He goes through very quickly and dives right into analyzing databases by using inventories, inventory sheets, inventory invoices, and how to find information, because these, if you were going to do backward engineering and reverse engineer or spy on a company, this is what you would do, is go dumpster diving, grab all their invoices, and this would give you, in another week or so, you'll understand how to reconstruct a database of your competitor. We'll show you how to do that. Okay, some more information about databases and how they relate. I'm going to give you a little better explanation because he jumps into this very, very quickly. But some of the vocabulary I like are highlighted. I like attributes, or the columns on the Excel spreadsheet, fields. And we'll talk about what entities are in just a second. Relationships, how he connects one record of information with other records of information. In other words, if this was an Excel spreadsheet, you can do computations on one sheet that references computations on another spreadsheet inside the same workbook. And that is a relational thing that's built right within Excel. Now, this is not an Excel class, but it's the same things we can also do inside relational databasing. Move through this quickly. He gives a lot of good examples. I've highlighted some stuff to pay attention to that I feel that will help. Here on page 9 through 22, we're going to hit this section of the chapter 1 again in just a second, but I just want to show you that we can take SQL just like we program in functional programming. How you've learned how to write pseudocode and flowcharts. Well, in SQL, we can do the exact same thing with flowcharting. It's called ERDs, Entity Relationship Diagrams. And these diagrams show entities, tables of data, a spreadsheet. And each spreadsheet has so many columns, but here you can see we have the name of the block of information, which is the very first line separated. And then the body of that block holds all the columns for that one spreadsheet. We'll go into this a lot more detail as in the second lecture, but for right now, just realize that we do have a visual way of producing pseudocode for our databases. This I've highlighted with the grapefruit color because the first illustration is what IT staff does. They have direct access to a database and a database management system. You don't want your users doing this. In the first picture here, this is a big no-no. You can't trust them. What you will find normally in the industry is this second picture here, where a user will talk to some type of interface, a program, a web server, and that program or web server will then go out to the management system, and it will then query the database, gather the information, and then daisy chain it back to the user's request. Most of this is explained in here. He does give some other types of databases that we'll take a look at in just a second as we go through this course. Advantages of a database and processing. Given 15 seconds, I'm sure you could come up with the exact same list. He goes through and then goes through great detail. None of this is highlighted. Disadvantages of a database. Yes, there are problems. I wanted to add security onto this course, but I've been asked to delay security for a more advanced course later on. A sample of a database. And in his, the author, he has three different case studies that he goes through and gives you examples step by step. He mostly focuses the book on Microsoft Access. We'll be studying more MySQL. But once we get these basic concepts down, you'll be able to easily shift from any database physical structure to another if we get these logical structures down first. Books, questions and answers, more examples upon examples upon examples. Another really good example of an ERD diagram, entity relationship diagram. You'll need to draw these for your final project. Final project's 25% of your grade, so this is something to keep in mind. Then he begins to introduce some of the case studies that he has. These case studies I've downloaded for you. They're in your student notes. Download them, open them up. In fact, the next lecture, or the third lecture, we're going to go and open up some of these Access databases and analyze how to build some of this. All right, there we are. That's chapter 1. So let me get that out of the way. Go back over here to my notes. Now what I'd like to do now is bring us back into our lecture notes. So we left off with chapter 1. Now, history of databases. Let's go out and take a look at a couple of sites that I have lined up for us to take a look at, just to give us some background on how businesses began to develop and store information. So my first one here, I love Wikipedia. It seems like it's the only encyclopedia that can keep up with the volume of data on the internet. And at Wikipedia, what they say here is that a database is nothing more than a computer software that stores information. They go through things like 1960s, the 70s, oh my god. So that's mostly the mainframes. They give you some vocabulary to talk about. And they start off here with the history, right about here we go. Mainframes and how they came up with different ways of doing things. They begin to codify ways to build relationships with different pieces of data. That there would be some type of parental piece of information that would have subdirectories underneath of it. And so the very first forms of databases really were called a hierarchy or a hierarchical database, which is nothing more than the file systems that we find on our computers today. You have your main folder at your C or root drive, and then underneath that one folder is all the other collection of folders that come down from there, and in each of these directories are stored additional files. That was the very first type of database that was constructed. We'll see that in just a second. In the 70s, they started getting into a thing called relational databases. Goodness sakes, 1970, I was a junior in high school. Most of my life has been spent watching the information technology industry grow. So relational databases was something that was brand new concept, invented by Ted Cobbs. And we're going to study some of Cobb's rules later in this course, another couple of weeks. Here we go. SQL. Now we're starting to get into what we're actually studying right now today. In early 70s, 1974, 75. Goodness sakes, by that time I'm out of community college and looking around. So, and starting my bachelor's degree. In 1978, you can see that this was the beginning of some serious real relationships and defining this information. By the time the 80s came around, now the demand for desktop computing and information down to the desktop actually forced the industry to make massive changes. And that's where DBase, one of the more popular ones, came around in the 80s. By the 90s, with the World Wide Web coming around, we had to start dispersing or distributing data across larger areas. In fact, in the late 80s was when the DNS, domain naming systems, went from the boot P protocol into domain, which was an automated database, distributed database. By the early 2000s, now we're getting into something that we are going to study in the last module, which is NoSQL. You have to understand that SQL has been around for the past 35 years. It's really an old technology. It works, and in the 90s, when object-oriented programming became all the fad, then they started thinking, how can we take databases and make them more object-oriented? But nowadays, we're looking at how to construct data from documents, like Mongo, Pouch, Couch, and we'll hear these words and other types of databases as we go further along. Other types of databasing systems are with XML, Extensive Markup Language, JSON, JavaScript Object Notation databases, Mongo, Couch. Here's some others. If you're interested in some of these, Apache Cassandra, very, very popular. In fact, Amazon is the one that uses Cassandra for its databasing system. Amazon? You've never heard of Amazon Books? How in the world do they keep their inventory? Yeah, that's the question. So anyway, here's a little bit of history about that. So one of the next things I wanted to show you is here is an article about the timeline of database history. I pretty much just covered that, but let's go back over to my notes and show you that in this one we have a history of databases, how databases have evolved. So database systems, here we go. Here's the actual timelines. 1968, I was a 8th grade at this time. See, literally, I grew up with computers. So by the 60s and 80s, we're now getting into non-relational databases, and the things that we are using today in this class have derived from these things that have happened 30, 35 years ago. So here's more of a timeline of what happened when, and you can double check my numbers there. The other one that we have is the Structured Query Language Database Management System. This is a free online book. Very useful book. In fact, I'd like to show you one page of it right now. Get rid of that. We're done with that page. Here we go. This book, Structured Query Language Database, supplements our text. Our author and our textbook does move very quickly. And here are the different types of classifications of databases. Hierarchical that I mentioned earlier, typically just a data structure very similar to your hard drive. Network databases became extremely popular in the 80s as networks began to grow down to the desktop. Relational databases was invented back in the 70s with Ted Cobbs, and we're going to study some of his rules in another week or so. Object-oriented databases, how they work, how they come about, and finally NoSQL. And then, oops, let me back up because I wanted to talk about these new SQLs that don't follow or maintain the ACID paradigm. There's a whole bunch of different jargon and words that have been created in databasing, and that is this one, atomic, consistent, isolated, durable. And if you'll read those letters vertically, ACID, that's the ACID paradigm. Most databases since the 70s tried to adhere to these concepts of building a database. And this is where Cobbs developed his rules for database normalization. And we'll master 3 of those rules out of his dozens. The other terms that you'll find in databasing is CRUD, but we'll save that one for another lecture.